Today we will continue our conversation about solving literal equations. Remember that a literal equation is an equation that is made up of multiple variables. In order to solve a literal equation, you have to make sure that you are given which variable it is that you are solving for. You cannot solve a literal equation and get a single value. We will be talking about a bunch of specific cases of literal equations this week. Today, we're just going to start with talking about two of them. So the first special case we're going to talk about is when we have something where we have a grouping happening. And typically groupings happen with parentheses. So when we have an equation that is a literal equation that looks, for example, like this one, this equation says solve y equals m times the quantity x minus x sub 1 for x, so it's telling us which variable to solve for, and then it says in terms of the other variables. And remember, that just means that those other variables will appear in our answer. So in order to do this, the first thing you're going to want to do is you're going to want to eliminate the value in front of the grouping using, and most of the time we used to distribute to get rid of the groupings, but this time we're actually going to use division. We're going to divide that thing off so that it isn't attached to the other variables anymore. So I'm going to start by rewriting the equation y equals m times x minus x sub 1. So when I'm saying dividing off, we're talking about this m, and we want to divide it because it's being multiplied. We want to do the opposite, which is division. We want to divide it off on both sides. So that's actually going to cancel my m's, which will eliminate this grouping. So then I have x minus x sub 1 on this side, and on this side we have y divided by m. So here, remember, it told us that we're solving for x. So when we're solving for x, one thing to keep in mind is I know it looks like both things on the right are in x. But variables with subscripts are different than variables without subscripts. So we are solving for this x right here. So in order to get that x by itself, I'm going to add x sub 1 to both sides. And the left side now looks messy. So I'm going to rewrite it so that I can see exactly what I have. I have y over m as a fraction, and then I'm adding x sub 1, and that is equal to x. And we actually, even though it looks sloppy, just solved that literal equation because we got x by itself in terms of x sub 1, y, and m, which is what we were trying to do. Give this example a try using what we just talked about as a model. Pause the video, work on it, and then once you're done, play the video back so that you can check your answer. Now it's time to check your answer. You should have gotten 5d over 11 plus 15. Remember, to divide off fractions, you need to remember to multiply by the reciprocal, which is what I did by multiplying over here the 5/11ths on both sides. When you multiply 5/11ths by d, remember d is technically a fraction with 1 on the bottom. So that's how I got 5d over 11 equals p minus 15. And then I added 15 to both sides to get p by itself. So these are two examples of how you can use eliminating groupings by division for literal equations. We're now going to move on to dividing off multiple terms. So first thing you need to do is you need to identify how many variables you will need to divide off and do it all in one step. And I'll show you what I mean by that. So this first example is g equals 2/3 mhv. And we're going to solve this for h. That means at the end we want h equals, so h by itself. And then we're going to have g, v, and m in our answer. So the first thing I'm going to do is I'm going to identify which variables I need to divide off, because these are all held together by multiplication. So the inverse operation would be division. So I'm solving for h, so that means I'm going to want to divide off the m and the v so that they can move away from h. So I'm going to divide that all off in one step. So I'm going to divide by mv. So now I have g over mv equals 2/3 h. The last step here, it says eliminate the coefficient last. And when it's a fraction, remember again that you want to multiply by the reciprocal. So when we're multiplying by the reciprocal of 2/3 on both sides, I'm going to multiply by 3/2. And I'm going to multiply by 3/2. So now I have 3g over 2mv equals h. And now I have h by itself. So I know it seems weird that we're eliminating our numbers after the variables, but that makes it look the most simplest and keeps it all together in one clean fraction at the end. One thing that I did note down here is, just like we said that subscripts separate variables from each other, capital letters and lowercase letters in literal equations are not the same term. They are not like terms, which will come in handy over here. So what I would like you to do is try the second example, pause the video, and then come back and push play once you're done to check your answer. So hopefully you got 4a over 3a, and remember those a's are not like terms, so it is okay to just leave them there. First thing I did was I divided off this a because I wanted to solve for b, so I needed to move the other variables away. And then I multiplied by the reciprocal of 3/4 on both sides, which is 4/3. And then I just smushed that fraction together by using multiplication. 4 times a is 4a. 3 times a is 3a, and I ended up with b equals, since we're solving for b, I know I'm done, b equals 4a over 3a. Use these notes to complete the back of your classwork. If you do not finish the back of your classwork, it is homework.